Okay, so in this video I'm going to go through question 2 of the January 2013 examination paper. So question 2 is a wide channel consists of two long reaches. The upstream one has a bed slope of 1 in 100 and the downstream has a bed slope of 1 in 2000. The Manning's n for both reaches can be taken as 0.03. So the first thing it asks us to do is sketch the possible profiles that can occur, and if the discharge is 5 meters cubed per square per meter, work out which one will actually occur. And part B asks in which of the two reaches will the hydraulic jump occur. So we've done a similar example in the lectures, and there's a similar example on the tutorial sheet as well. But what I'm going to do, I'm going to give you a full solution of this question. So the first thing I'm going to do is draw the profile, draw the bed slopes. So you've got an upstream bed slope, and then you've got a downstream bed slope. So it says the slope of this one is 0.01, and the bed slope for this one is 0.05. Yep. And the other parameter that is given is small q is 5 meters cubed per square per meter, and then it also gives you Manning's n, which is equals to 0.03. So you've got reach 1 and you've got reach 2. So those are the parameters and information that is given in the question. So part A is sketch the possible profiles that can occur, and if the discharge per unit width is 5 meters cubed per square meter, work out which one will occur. So the first thing we're going to do is calculate YC and then YN. So those are the first two parameters we need to calculate. So first of all, YC. So YC is equals to cubed root of small q squared over g. So that equals to 5 squared over 9.81 cubed root, and you get equals 1.36 meters. Yep. Now you need to calculate YN. YN you calculate by using the Manning's equation. So the Manning's equation is Q equals 1 divided by N times R to the 2 over 3 times slope to the half times A. Yep, so that's Manning's equation. We know what R is. R is equals to area divided by the wetted perimeter. Yep. So we sort of have a problem here because we've been asked to calculate YN, but we've got R. R is equals to area of the wetted perimeter. So that is equals to B times Y over B plus 2Y. So you've got Y at the top and Y at the bottom, so it's difficult to rearrange this equation for Y. However, in the question it states it's a wide channel. When you get a wide channel, you need to remember R is equals to I. So that simplifies the problem for us. So this equation now becomes Q equals 1 over N times y to the 2 over 3 times s to the half times a. Yep. So you can rewrite this equation again by doing q equals 1 over n y to the 2 over 3 times s to the half, and area is just b times y. Yep. Now we can get rid of the b by using the relationship q is equals to small q times b. Yeah. So what you get is q b is equals to 1 over n times y to the 2 over 3 times s to the half times b times y. Yep. So now you can divide by b, and what you get is q is equals to 1 over n times y to the 2 over 3 times s to the half times y. Yep. Now you can collect the y terms. So if you collect the y terms, the equation becomes q equals 1 over n times y to the 5 over 3. So you're collecting y to the 2 over 3 plus y to the power 1. So that becomes y to the 5 over 3. And then times slope to the half. Oh, come on. Yep. So now you've got, this is the final form of the equation for yn. Now you can rearrange this equation to calculate yn. So you get yn is equals to q n divided by square root of the slope. Yep. And yn is 5 over 3, so that's 5, and it's all cubed. Yep. So now you can calculate yn1 and yn2. So yn1 is equals to 5 times 0.03 divided by square root of the slope in reach 1, so it's going to be 0.01. So if you calculate that, you get 1.275 meters. Now you do the same with yn2, and you get 5 times 0.03, but this time the slope you use is this for reach 2. You get 0.5, that's all cubed, and then the answer you get for that is 3.133 meters. So So now you've calculated YC and YN. So now you can draw the profiles. So you go first reach and then second reach. So if we first draw YC, so you got YC. Yep, so that's YC. Now if we draw YN1, the value you got for YC is 1.36 meters, and the value for YN1 is 1.275, so it's lower than the YC line. So it's here. Yeah, so that's YN1, and then YN2 is higher. So yeah, the line goes there. Now, the possible profiles that can occur. So in this channel, what you have is a steep channel because the YC line is greater than the YN line, and in the downstream channel, you've got a mild slope because the YN line is greater than the YC line. So you've got a flow coming down in reach 1, and then what it needs to do, it sort of needs to meet the flow in reach 2. So the flow in reach 1 has to increase for it to reach the normal depth in reach 2. So the profile that will occur, possible profile that can occur, is an S1. Yep. Or the profile that can occur is an M3. Yeah. So the reason it's an S1 or an M3, so the flow has to reach this level here. Yep. So the water level has to increase. Now it'll either increase in reach 1 or it will either increase in reach 2. And the way it will increase is through a hydraulic jump. So the hydraulic jump will occur either in reach 1 or it will occur in either reach 2. So if you assume that it's going to occur in reach 1, then the water level has to increase, so it's going to be an S1 to reach this level. Or if you assume it's going to occur in reach 2, then it's going to be an M3, as the water level has to increase and reach that level. So it's an S1 or an M3. However, we don't currently know which one of the two will actually occur, because we don't know which reach the hydraulic jump occurs in. So this is the next part of the question. So in which of the two reaches will the hydraulic jump occur? So for part A, we've sketched the possible profiles, and if the discharge is 5 meters cubed per second, it says work out which one will occur. You will work out which one will occur by answering this question, this part of the question. In which of the two reaches will the hydraulic jump occur? Yep. So all of this would give you 12 marks, working out YC, yep, and then manipulating the Manning's equation to work out YN1 and YN2, and then drawing the actual profiles. This will give you 12 full marks, yep, showing the profiles at the end. Now the final thing is to work out in which reach the hydraulic jump occurs. So you use the hydraulic jump equation, so you know that is y2 equals y1 over 2 square root 1 plus 8 f of r squared minus 1. Yep. So first of all, we calculate f of r squared, which is equals to v squared over g y. V is equals to q over a, because we don't have big Q but we have small q, so that's just qb over b times y, which is area. Yep. So the b cancels out and you just get left with q over y. So you can sub this back into this equation. So what you'll get is f of r squared is equals to q squared, yep, g times y cubed. Yep. Because v was squared, so all of this is squared. So q squared and y squared. And when you sub this into here, you get q squared g, and because there's already a y there, so it goes y cubed. So now you can work out the Freud number. So you get 5 squared over 9.81 times, we're going to use y1, which is 1.27 cubed. Yep. And the answer you get for that is 1.244. The reason we're using this value is our assumption is that the hydraulic jump occurs in reach 1. Yep. Alternatively, if our assumption was that it would occur in reach 2, we wouldn't use 1.27, we would use 3.133. Yep. So now that you've calculated that, you can work out what y2 is. So you put that back into the equation. So y2 is equals to 1.27 over 2 1 plus 8 times 1.244 minus 1 equals 1.467 meters. Yep. So what that is showing is, if this is 1.27, this is 1.467. So it's showing a hydraulic jump has occurred in reach 1. Alternatively, you can do this this part of the problem again. So you can calculate y2 again, and instead of using 1.27, you can use 3.13, calculate the Freud number, and then calculate y2 again. And what you'll find if you use this value is you'll see y2 is lower than y1, which is impossible. Yep. Because for a hydraulic jump to occur, y1 has to be smaller than y2. Yep. So our assumption that the hydraulic jump occurs in reach 1 is correct. Yep. So the profile which occurs is an S1. Yep. So that would then give you 8 full marks. Yep. So writing down the equation for the hydraulic jump, writing down what your assumption is, calculating the Freud number using the parameters that are given. Once you've calculated that, using the correct y1 value, putting the values back into the hydraulic jump equation, and then calculating y2. Based on that, the final sort of sentence to conclude the question would be that the profile that occurs is an S1 and not an M3, and that would give you full marks for this question. So you'd get the 20 marks that are available for this question. So that's the end of that question. I hope that sort of makes it fairly clear.